Hello, my name is Soni Midha, and I am a virtual content specialist for Algebra 2. And so today I'm going to be focusing on the Explore activity from Unit 6, Day 23. How do we relate the features of the graph of a trigonometric function to the terms in its equation? So the goal of this task is essentially to match equations and graphs together, right? Match equations and graphs of cosine and sine functions with each other. And I'll show the activity in just a moment, but basically there are 4 different graphs and 6 different equations. So students have to match the equations with the proper graph, noting that some of these graphs may have more than one equation. And so I think the best way to execute this activity is through a Desmos card sort. And I've actually included in the supplemental resources, I've included the teacher link for the activity that I'll show you, the Desmos one. So you're free to use it. You can just use it as is for your class, or you can edit it and do whatever you need as you see fit for your students. But I am going to explain how to create a card sort as well, in case some of you who are not familiar with doing it. So just keep that in mind as well. Okay, so here goes. When you are creating a card sort on Desmos, you go to teacher.desmos.com and then you click on new activity, and this is what it's going to look like. Slide 1 to be specific. This is what slide 1 would be. And so it's blank. So you're going to just kind of scroll down to where it says card sort, click card sort, and you'll see there are 3 buttons. There's 4, but there's 3 we're going to talk about. Math or text, image, and graph. So I've actually taken screenshots of the 4 graphs that need to be used for this activity. So in order to include and to insert those, I would click on image, and this box pops up, and it says add an image by dragging it here or clicking to upload. So I'm going to go ahead and click to upload. I find my file and I go ahead and insert it, and there it is. Now I always click large card. It's not mandatory, but I find it is really helpful for my students. They can see the image. It's bigger and it's just a little bit more clearer visually for them. So I want to do this 4 times, insert my 4 graphs. And then once I do that, I want to insert my equations. So to do that, I'm going to go ahead and click on math or text. Now I want this to be in a nice format, in proper math type format, if you will. So in order to do that, I'm going to click on this radical sign. The square root sign is the type math button on Desmos. And once I do that, I'll be able to type my equation nicely. So my first equation is y equals negative cosine theta. So I just write y equals negative cosine. And I always just write the word because it pops up as the symbol. So there you go, negative cosine theta. Again, I click large card, and I do this for all 6 equations. So this is what the card sort should look like. Again, you've got your 4 graphs, your 6 equations. And as always, before sending this to students, you always want to preview it, make sure it looks okay. And so this is what the card sort looks like. Now, I always encourage my students to click on the enter full screen button. The reason for that is they have more space to work, which is always helpful. And just a reminder on how this works for those of you who are unfamiliar. I'm just going to move these around so I don't have anything overlapping first. And again, encourage your students to do that. But once they figure out which graphs match which equations, what they need to do to actually put them together, to sort them together, they want to take the equation, and let me look at which equation I want to use. I'm going to use this equation right here, 3 sine theta minus 2. So I notice that this equation is going to match graph B. So what I'm going to do is I'm going to take this equation and I'm going to drag it over to card B. And I'm going to drag it over until I get that blue border, right? It's basically highlighted. That means that once I let go of my equation, I'm going to do that right now, the 2 cards have been sorted. So that's how students should be sorting these cards. Now, one thing that I included in this activity is actually like a self-checker for students, which I find very helpful. Again, if you don't want to keep that, you can always get rid of it. But I find it helpful because instead of, you can still check their work while you're through the teacher dashboard, but by having a self-checker, students don't have to keep asking like, oh, is it correct? Is it correct? Is it correct? So notice what happens on the next slide. It'll tell me how many cards I have correct so far. So I've only done 1 card sort. If I go next, it says you currently have 2 cards sorted correctly. Please go back and keep sorting until you match them all correctly, right? I want them all to be correct. So I would keep going back and I would keep matching my cards with their equations. I'll do 1 more just to show you what it looks like. Okay, now it looks like I have 4 cards. Are they correct? you currently have 4 cards sorted correctly. So this is really great because again, it allows students to sort of just get verification without having to wait for you. And feel free to take this out if you feel like it's too much, but I do find it very helpful for my students. Okay, a couple of things to just sort of keep in mind while students are working on this card sort, like just sort of thinking about what students might do in order to help, match equations with their cards, with their graphs rather. They might look at the equations and evaluate some of these equations, these functions, basically by thinking about certain inputs, right? Like theta is equal to 0 or theta is equal to pi over 2, and then basically evaluating the function to help them eliminate possibilities when identifying the correct graph. So that's one way. And definitely if students are not sure how to begin matching, definitely that might be the way to go. Like try to suggest that they try a few strategic theta values. For example, you can ask students to name the input values for cosine that have integer outputs. That might be a way that they could sort these. Another way that students might complete this activity when it comes to matching is to identify the maximums and the minimums of the graphs and trigonometric functions, right? So they might actually already notice, like, with 3 sine theta minus 2, what the maximum and the minimums are, and that might help them figure out what graph it matches with. And then another idea that students might use to complete this matching activity is really to just think about the midline, the amplitude, and the horizontal translation, both graphically and in equation form. So 3 different ways that your students might actually be figuring out how to match them. Definitely encourage your students to use the structure of the equation to identify important features of the corresponding graphs. And again, if students are having a tough time, just sort of suggest one of these strategies for them. Now, once they finish sorting these cards out, you'll notice that the next slide after the self-checker is 4 slides that look kind of the same, but the graphs are different. So you'll see here, it's a picture of graph A, and it's saying the equation I chose for the graph was because, the reasoning. So you want students to complete this, or you want them to include the equation and explain why they picked what it was. But on the teacher side, I just want to show you what that looks like. So this is what the slide looks like. You'll notice the text input is completely blank. And so in order to see where I put that text in, if you just hover over this button, the computation layer, if you click on it, you'll see a little bit of code, just a little bit of code. It says initial text colon, the I is lowercase, the T is uppercase. And then in quotations, you'll notice that that's the text that was on the slide that students see. So if you want to change this question, if you want to change it, so however you want to change it, you can just do that here. But again, make sure that the text you want students to see is between those 2 quotations. So you'll see I have that here 4 different times. And again, thinking about like when students are filling this out, if they're having a tough time sort of explaining why they picked what they did, just sort of remind them, well, what was their strategy, right? Did they pick strategic inputs? Did they identify maxes and mins, midlines, and things like that? Now, the last slide is a summary. And so you can just ask students, how do we relate the features of the graph of a trigonometric function to the terms in its equation? Now, once they have finished this activity, you definitely want to have a conversation and definitely like invite students to explain their thinking from slides 4 through 7, probably in just sort of the different types of reasoning, if you will, like there's sort of strategies behind it. So like I would initially invite students who evaluated the trigonometric functions to help identify the proper graph, right? The inserting the strategic inputs. And so you can have this conversation by sharing your screen, sharing their work while once they finish, and you can have this conversation via the chat, or unmuting yourself, anything like that. But yeah, so definitely like invite students who evaluated the trig functions first, and then maybe have a conversation where you're inviting students who looked specifically for maxes and mins, and then having a conversation with students who use the structure of the equations to deduce important properties of the graph. And what's nice is that because you can see this on the teacher dashboard, you can tell who used which strategy. So just sort of thinking about, okay, well, who am I going to ask to share out for the first strategy, the second strategy, and the third strategy? So again, this activity will be up for you in the supplemental resources. You are welcome to edit it as you see fit, or just use as is.